Many of the decisions that are made during the design phase of a new product will in some way affect how easy it will be to recover its materials through recycling. There are fortunately general principles that can be applied to take the recyclability of a product into account while designing. In this video we will discuss design for recycling guidelines at the product level, the component level and the material level. In design for recycling, the starting point is our knowledge of the actual recycling processes that the product will most likely be subjected to. For electronic products, this is usually manual separation of hazardous or valuable components, followed by shredding of the largest part of the product. Let's start with the product level. In general, reducing a product's overall complexity will improve its recyclability, so it's usually helpful to minimize the total number of components. Also consider whether modularity can facilitate the separation of your product's components and materials. Or perhaps you can design your product in such a way that it will easily break apart during initial mechanical opening and shredding. Since waste electronic equipment may be partially dismantled before it is shredded, also think about how easy your product can be disassembled. Finally, let's look at the fasteners that keep product together. The most important thing is to avoid creating permanent connections. Instead, consider using click fingers, snap fits and screws that easily break down. Try to reduce the complexity of your product by reducing the total number of fasteners as well as the different type of fasteners that you use. Make sure that fasteners are protected from wear and corrosion, so they can be broken down at the product's end of life. Whenever possible, opt for fasteners that can be removed with standard disassembly tools and ideally with as few different tools as possible. This brings us to the component level. At the start of the recycling process, hazardous components and substances such as batteries or liquid coolants are manually removed. The same may apply to relatively valuable items such as high-end printed circuit boards, motors or easy accessible cables. Therefore, it is important that these components are easily identifiable and accessible. Disassembling them should be as easy as possible. An option is to design hazardous or valuable components so that they can be manually separated from the rest of the product in a single step. Always avoid permanently fixing these components to other parts by, for instance, gluing, welding, or insert molding. Finally, whenever you need to use cables and wires in your product, try to limit their total number and length. From the component level, we now move on to the material level. The primary aim is the recyclability of materials you use. Try to determine whether a material can be easily recycled and, whenever possible, try to use materials that have already been recycled. This will help to increase demand for recycled materials, which will make further investments into recycling activities more viable. Another goal is to keep recycled streams as pure as possible by preventing pollution with other materials or contaminants. Reducing the number of different kinds of materials that are used in your product will generally make it easier to recycle. Yet, in complex products such as electronics, this can be a challenge. Therefore, try to apply this principle also at the level of separate assemblies and subassemblies. Either try to use a single material or avoid mixing of materials as much as possible. Do not, for example, combine two different materials through 2K molding. This makes it very difficult to separate them, which will either result in one of the materials polluting the other recycled stream, or both materials ending up as waste. The same thing can happen when you attach or screw a ferrous metal to a non-ferrous metal. If small fragments of the metal remain attached after shredding, one of the two recycled streams will likely to be polluted. An example of this are magnetic components on PCBs, which during recycling may cause the PCB to end up in the ferrous stream, potentially wasting the valuable non-ferrous metals that are on it. Furthermore, avoid using materials, substances or additives that are harmful to the environment and human health. These are the substances of very high concern defined by the European Union, REACH regulation, and those included on the SIN list, which may prevent the material from being recycled in the future. Taking these considerations into account during the design process will improve the recyclability of your product. Note that design for recycling is not the only circular strategy to take into account while designing a product. Especially in the case of connections, design for repair also requires attention. If you are unsure about the impact of a particular decision, consider consulting directly with recyclers, preferably those located within the market you're designing for.